Saxon Algebra 2, Lesson 66. Welcome, students, student, one at a time. Jayla and Lydia, are you ready? Lesson 66. It's a very useful and fairly straightforward lesson. Two topics. The first one we've already worked with. It's called signs of fractions. And the idea is very practical. Let's say that you're trying to add a pair of fractions, and they're algebra fractions with letters and numbers flying everywhere and minus signs. And you look at this because you know that the first thing you have to do when you're adding fractions, denominators match. And you look at these and you go, wait, they both have an x, they both have a 3, but the signs are messed up. And you realize, wait, if I could change the signs, probably of this one because it's uglier, x minus 3 looks cuter than minus x plus 3. If I could change the sign of that, I would be a much happier person. So that's our goal. That's the reason why we want to play with the signs of our fractions. Now, to back up, there are a lot of ways that we can express signs in fractions. There are really 3 signs that relate to any particular fraction. There's the sign of the numerator, there's the sign of the denominator, and then there's the sign out here that tells us that we're adding or subtracting it. So we can tinker with any one of those signs. For example, if we want to multiply this by, well, let's just look at other variations. It could be like this, right? So here's option A. That's going to be positive 3 over 4 when we simplify it. This one, fraction B, is also going to be positive 3 over 4 because these two minuses are going to cancel, and then that's a positive. What about this? See? This is also going to be positive 3 over 4 because these two will cancel. And if we wanted to, this one is not very typical. Because typically we apply the minus sign to the numerator, but if we wanted, we could apply it to the denominator and also get positive. But this one is kind of not really normal. These are the presentations that are more typical. And then we could also do minus 3 over minus 4. We could play around with the minus sign out here and all 3 of them, and this one would give us a minus 3 over 4 as our final answer. There are more permutations, if you will, but this gives you an idea of how we can adjust our minus signs. So going back to our original problem, we see that if we multiply this bottom half by minus 1, then it would look just like that, and we wouldn't have to do any more work. So that's what we're going to do. Let me copy it. Block all that off. Let's get our original problem down here again. 7a over minus x minus 3. Okay, so what we want to do is we want to multiply top and bottom by minus 1 because that will fix this. And then we'll decide how to handle that. So, I'm going to ignore the top for now, and I'm just going to fix the bottom. It will, oh, this was a plus, sorry. So it becomes x minus 3 when we multiply this across. That makes us very happy. Now, we have an option here. We can either say this is minus 7a. Right? Because then what we would be doing is we'd be leaving this one alone and we'd be changing that one. That works, right? But that's messy. Look at all those minus signs. What I would rather do, so this is kind of, you can look at this as cleaning this up. We would turn that into a plus, positive 7a over x minus 3. So you can see this as the first step and this as the second step. Or, if your brain prefers, we can just shortcut and not even look at that step and go, okay, we're going to take this minus 1 and apply it to the outside, and that's what we get down here. So there are two ways of looking at it. Either way, we're going to end up with a positive 7a and an x minus 3 in the end. So now we can add the 1 plus 7a over the matching denominator, x minus 3. Final answer. So, super useful tool. There's one more problem in this part of the lesson. And it goes like this. We are to add 4x plus 5 over x minus 3. This one has a positive, a plus sign in the middle, so okay, that's good to know. And there we have it. We have a denominator that looks a lot like the first denominator, but the signs are backwards. So we know we want to multiply this by minus 1, and Hannah Cranny is quite sure that we need to do the top by minus 1 as well. So, first fraction, again, stays exactly the same. We're using the third rule of algebra here. We don't have an equal sign, so we're multiplying top and bottom. Everything fresh and clean. And now, let's do, I want to keep the plus sign in between, because I don't want to put that minus sign there. So we're going to do the bottom first, and it becomes positive x minus 3. And then what we will do is apply the minus signs. Instead of applying it out here, we're going to apply them to this. So it will be minus 2x plus 3. When we go to add these, we'll have 4x plus 5 minus 2x plus 3. The minus sign was distributed to the 3. It just turned it positive. Okay, now we are ready, and it's all over x. And now we can add some like terms. 4x minus 2x is positive 2x, and 5 plus 3 is 8, all over x minus 3. An eagle-eyed student might go, oh, but wait, we could factor that. We could pull out a 2 and go x plus 4. Over x minus 3. And we could do that, but there's nothing to cancel the 2 against, so it doesn't change the answer. It's just a different form. Either of those are fine. There's no reason to do this extra step, so this is the ideal answer, but this is perfectly fine. On a test, I would accept that. Full marks. Okay, so this is part A, signs of fractions. How can you tinker with parts of your expression to change the signs the way you want? Useful and cool. All right, part B. Also useful and cool. It's called a 30, 60, 90 triangle. We're changing over to the trig world, and we're going to talk about triangles. So, in this triangle, what I want you to imagine is an equilateral triangle, which means that all the sides are the same. Actually, it's called a regular triangle because the sides are the same and the angles are the same. So, this is our triangle. It's kind of a backwards play button, isn't it? So, all of these are 60 degrees. And instead of making each of these sides equal to the unit of 1, we're going to make each side equal to 2. You'll see why in a minute. So all of our angles are the same, all of our sides are the same length. Now, we're going to chop it in half. That way. Okay? And I'm going to redraw just the top half. Right? And it helps, when we're trying to memorize this, it helps to kind of keep in mind that the other half of that triangle is down here. We're not paying any attention to it, but we kind of are. Now, what we're going to do is we're going to recreate the lengths of the sides and the measures of the angles based on this new chopped up version. So the first thing we know is that we have a right angle right there, 90 degrees. This angle is unchanged, so that's 60 degrees. This angle, we chopped it in half. It used to be 60, so now this is a 30-degree angle, and there we have the name 30, 60, 90-degree angle. So this is a 30, 60, 90, where this one was a 60, 60, 60. So we started with something super easy to remember, and then we chopped it in half. Oink. Okay, so the angles are easy to figure out. Now we want to talk about the lengths of the sides. This hypotenuse, it's become the hypotenuse that you. This is the same. So we mark that as 2. This side was cut in half. So we only have half of the original side, which is 1. That's why we made all the sides 2 instead of 1 in the beginning. It's because we wanted, when we chopped this in half, we wanted it still to be a nice, easy number. So we made all the sides 2 to begin with. So now this chopped in half side is 1. That leaves the question of this guy. We're going to call him x for right now, but we're going to give him a value in just a second. We want to know the value of that side. Well, our friend Pythagoras has it all figured out for us. 1 squared plus x squared equals 2 squared. That's the hypotenuse. These are the 2 legs. Remember, a squared plus b squared equals c squared is our Pythagorean. So all we have to do is solve this, and we will have the length of that side. 1 squared is 1 plus x squared equals 4. Subtract the 1. I'm just doing some basic algebra here. X squared equals 3. So this side equals the square root of 3. We don't have to worry about positive, negative, because there's no way that this is negative square root of 3. That doesn't make any sense. So we now have, now that we know what it all means, my angles might not be sized perfectly, but I know I have one smaller angle and one bigger angle. The bigger one is the 60, the smaller one is the 30. This is the one that got chopped in half. This is the 90. And then this side didn't get cut at all. This is 2. This is the side that got chopped in half. So that's a 1. And then this is the hardest part to remember, square root of 3. 1, 2, square root of 3. This we are going to memorize, and what that means is that when we're doing trig problems with 30, 60, 90 triangles, we do not have to use our calculators. We can use these ratios, and I'll show you how. We're going to do a problem in just a second. We're going to be able to use these ratios to find sine, cosine, and tangent, right? If we're standing here, sine would be opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. We can use those ratios instead of having to grab our calculators. That's cool, right? So let's flip over and change back to purple, because that's just how I'm feeling. And now we'll do a problem, just one, that requires us to use these triangles. When you look in the book, you'll see that John draws his 30, 60, 90 a different way. It makes less sense to me the way that he does it. I like it my way. So I look at the picture, and it says use similar triangles to find x and y. And then John has drawn a triangle, but I'm going to change it. His is standing up. I want to draw it so it matches to the way we drew the triangle. So I'm drawing my 30, 60, 90 triangle. I remember, okay, there's the 90. This is 60. This is the one we don't chop. This is 30. It's the one we do chop. And then this is the way the sides go. Okay, so this is our, we call them reference triangles. This is our 30, 60, 90 reference triangle. We're going to memorize one other, and it has a different name. So this is the 30, 60, 90. Now, I'm going to take John's picture in the book, which you can see, he's drawn it so the 60 is there. I want the 60 up here. So I'm going to flip that triangle as I draw it so that it orients itself to look like mine. So I'm going to draw another one right down here. And I know that this is where I want my 60, this is where I want my 30, and this is where I want my 90-degree marker. And now I'm going to put in the sides. Between the 60 and the right angle, he has a y. The hypotenuse is 5. And the other leg, the long leg, is x. Okay, so we're supposed to solve for x and y. Okay, so just like any other similar triangles, we look for a pair of matching sides. There's our anchor proportion. We're going to do top to bottom in all of our fractions. 2 over 5 equals, and let's do x first, square root of 3 over x. We're just using basic proportion because we know these are similar triangles. They have matching angles, even though the sides are different. We can see that. And we just set up the proportion. Hypotenuse over hypotenuse, long leg over long, top, bottom, and now we solve. So I'm going to cross multiply. 2x equals 5 times the square root of 3. We're not going to let that bother us. It's just going to stay square root of 3. And then we divide by 2. And that equals x. Now, is that a satisfying answer? You might not feel like it, but that's a perfectly fine answer. It's 5 times the square root of 3 over 2. Hard to visualize, but whatever. Okay, and then for proportion. And then this time we'll use the short leg, equals 1 over y. And then we'll solve the same way. We'll cross multiply. 2y equals 5. And then just divide by 2. That's a little bit more satisfying. But we'll get used to it. That's a perfectly lovely answer. So this is a great example of how we can use this 30, 60, 90, this reference triangle, to solve a trig problem without having to use our calculators. And that is the end of lesson 66. I hope you enjoyed it as much as I did.